Welcome to this explainer. Today, we're going to pull back the curtain on a mathematical pattern, one that shapes our world in some seriously beautiful and honestly unexpected ways.
So, let's just dive right in with the big question. You see these incredible patterns in nature, right? Are they just a happy accident? A coincidence? Or is there a simple rule behind it all? Something anyone can get? Well, stick around because the answer is pretty cool.
Okay, so the first thing you need to know is that this pattern, it is not random. Not even a little bit. It's actually a very specific sequence of numbers, and it shows up almost everywhere you look, kind of hiding in plain sight.
No, seriously, we are completely surrounded by this mathematical code. I'm talking about the way trees branch out, the spiral of a whole galaxy, and most of the time, we don't even notice it. It's like it's a fundamental part of the universe's design language.
And here's the crazy part. You look at these designs, right? They seem so incredibly intricate, so complex, almost impossibly so. But the reality? They all boil down to one single, surprisingly simple rule.
So, what is this secret code? Well, you don't need a secret decoder ring for this one. In fact, let's crack it together right now. All right, so here's the formal definition. And yeah, it sounds a little dry, a little textbooky, but honestly, the best way to really get this is to just build the sequence ourselves.
Okay, let's do it. It's actually this simple. You start with two numbers, 0 and 1. Now add them together. What do you get? 1. Easy, right? Now you just take the last two numbers in the sequence, in this case 1 and 1, and add them together. You get 2. Now you have 1 and 2. Add them, you get 3. See? You just keep repeating that one simple step. Add the last two numbers.
And just like that, this super simple process gives you the famous Fibonacci sequence. It goes on forever, of course, but these first few numbers, these are the ones you're going to see popping up all over the place.
Okay, so now we know the code, but that leads to the really interesting question, right? Why does nature use this sequence so much? I mean, it can't just be because it looks good.
And this is the key, the really crucial insight. The Fibonacci sequence isn't just some pretty pattern. It's nature's ultimate hack for efficiency. It's the absolute best way to grow, to pack things in tightly, and to build structures that are both strong and get the most resources, like sunlight. And once you know what to look for, you start seeing this principle of efficiency everywhere. The seeds in a sunflower head, the little scales on a pine cone, they arrange themselves in these perfect opposing spirals that follow the sequence. Why? Because it's the tightest possible way to pack them in, with absolutely zero wasted space. Even the way leaves grow around a stem, it follows this pattern. It's all to maximize sunlight and make sure the new leaves don't block the older ones. It's just a perfect system.
All right, you think that's cool? Let's dive into what is, for my money, the most fascinating secret of this whole sequence. Because believe it or not, there's another layer to this mathematical magic.
Okay, watch this. Let's do something a little weird. We're going to take any two numbers from our sequence that are next to each other and divide the bigger one by the smaller one. So let's try 5 divided by 3. What do we get? Something like 1.666?
All right, let's try the next pair up. 8 divided by 5, the result is 1.6. Huh. Are you noticing how it seems to be getting a little closer to some specific number? And the next one, what about 13 divided by 8? That gives us 1.625. Do you see what's happening? The further we go, the bigger the numbers we use, the more that result starts to zero in, getting closer and closer to one very, very specific number. It doesn't matter how far down the line you go, that ratio will always get closer and closer to this number, about 1.618. Now, this isn't just some random number. It's one of the most famous numbers in all of mathematics. It's a special constant known as the golden ratio, or phi.
And here's where it gets really wild. This exact same ratio has been obsessed over by artists and architects for centuries. Why? Because for some reason, proportions based on the golden ratio are just aesthetically pleasing. They feel right to the human eye. It's why you can find it in masterpieces from the Parthenon all the way to the Mona Lisa.
So what does all this mean? I mean, we started out looking at a pattern in flowers, and somehow we ended up talking about classical art. Let's try to bring this all together.
Think about the journey we just took. We started with this mysterious, beautiful pattern we see all over nature. Then we cracked its code and found out it was based on a ridiculously simple rule. We realized it's basically nature's master algorithm for being efficient. And then we uncovered its deep, deep link to the golden ratio, a fundamental constant in both art and math. And that,
right there brings us to the biggest takeaway of all. It seems that the most profound, complex, and elegant structures in our entire universe, from a tiny little seashell to a massive swirling galaxy, they often come from the simplest possible rules. Just one simple instruction, repeated again and again, can literally generate infinite beauty.
So I'll leave you with this final thought to chew on. If a rule as simple as just add the last two numbers can be responsible for so much of the beauty and order in the world around us, what other simple patterns are we overlooking? What other secrets are just hiding out there in plain sight, waiting for us to notice?